Hello Internet, Parag Dhawan here. We are on day 9 part 3 of Kaggle's 30-day machine learning challenge. In today's video, we will see tutorial on model validation. We have built our first model. In this lesson, we will learn about model validation, how it is the measure of the quality of our model. What is model validation? You will want to evaluate almost every model you ever built. In most applications, the relevant measure of model quality is predictive accuracy. In other words, we build the model prediction be close to the actually happens. Many people make a huge mistake when measuring predictive accuracy. They make prediction with their training data and compare those predictions to the target value in the training data. You will see the problem with this approach and how to solve it in a moment, but let's think about how we would do this first. You would first need to summarize model quality into a understandable way. If you compare prediction of actual homes for 10,000 houses, you will likely find mix of good and bad prediction. Looking through a list of 10,000 predicted and actual values would be pointless. We need to summarize this into a single metric. There are many metrics for summarizing model quality, but we will start with one called as mean absolute error. Let's break down the metrics starting with last word error. Prediction error for each house. Error is equal to actual value minus predicted value. So if the house cost is 1,50,000 and your predicted it would cost 1 lakh, the error is 50,000. With mean absolute error matrix, we take the absolute value of each error. This covers each error to a positive number. We then take the average of those absolute errors. This is our measure of model quality. In plain English, it is said as on average our predictions are off by about X. To calculate real absolute error, we first need a model. This is built in a hidden cell below, which you can review by clicking the code button. So, reviewing the code, we are importing pandas as PD. We are storing the file path in a variable. Using pandas read CSV function, we are reading the CSV file and storing it in a data frame Melbourne data. Then we are dropping the NaN value using drop NA function. So we get the filtered Melbourne data as a data frame. Now we are separating the predictor variable by filter Melbourne data dot price. We are segregating feature in a list. So name of the feature inside a list is the Melbourne feature. Then filter Melbourne data applied to this feature will return features of our model. So we have predictor and the features. Using scikit-learn.tree, we are importing decision tree regression model. We are creating a model object of decision tree regression, storing it Melbourne model object. Then we are fitting this object to the features and predictor variable. Click on the cell and run the cell. By doing this, you have created a model which is a decision tree regression model. Now we will compute mean absolute error. So scikit-learn has metrics. From scikit-learn.metric, we will import mean absolute error. We will using the model.predict function, we will compute prediction of house prices. Using mean absolute error function, we will compute the mean absolute error of actual predictions and prediction made by the model. So we now have mean absolute error, which is $434.71. The problem with in-sample scores. So this was the analysis taken on the dataset itself. The measure we just computed can be called as in-sample score. We used a single sample of house for both building the model and evaluating it. Here's why this is bad. Imagine that in a large real estate market, door color is unrelated to home price. However, in the sample of data you used to build the model, all the homes with the green door were very expensive. The model's job is to find pattern that predict home prices. So it will see this pattern and it will always predict high prices for homes with green color. Since this pattern was derived from the training data, the model would appear accurate in the training data. But if the pattern does not hold when the model sees new data, the model would be very inaccurate when used in practice. Since model practical value come from making prediction on a new data, we measure performance on the data that wasn't used to build the model. The most straightforward way to do this is to exclude some data from the model building process and then use those to test the model accuracy on the data it hasn't seen before. This is called as validation data. So from the training data, we are segregating some data for validation of our model, that is called as validation data, and now we are coding it. The scikit-learn library has a function train test split to break up the data into two pieces. We will use the sum of the data for training to fit the model, and we will use other data as validation data to calculate mean absolute error. Code for it is: from scikit-learn library, using model selection, we are importing train test split function. Train test split function is applied to features and predictor. Random state is equal to 0. This will divide the dataset into train set, validation set, train predictor, validation predictor. Then we will create a decision tree regression model using decision tree regression function. We will fit the model on training data. We will predict the value on validation of X and store it in validation prediction. Then we will compute mean absolute error on validation Y, which is actual output, with validation prediction, which will give you mean absolute error. Click on the cell and run the cell. You can see now the mean absolute error is 2,57,503. Your mean absolute error for the in sample data was about $500, and out of sample it is more than $2,50,000. This difference between a model that is almost exactly right and one that is unusable for most practical purpose. As a point of reference, the average home value in the validation data is $1.1 million. So the error in the new data is about a quarter of the average home value. There are many ways to improve this model, such as experimenting to find better features or different model types. That's it for this video, where we have studied model validation. In the crux, we created the model and then predicted the model on actual features and predictors. And the next part, we divided our data set into trained and validation set, created our model on the train set, and assessed the quality of the model using the validation set. And we found that if you use in sample model, the model was not giving as much accurate result as when it was compared to unseen data. Thank you. Thanks for watching. Do hit that subscribe button for more such technical content. See you in the next video.